dv dx, and that's your choice. You could choose wrongly or wisely. You'll figure out pretty quickly whether you've chosen the wrong one. So we have u, this is not a great pen, we have v, du dx, and dv dx, that's dv. Okay, so you write these four things down, and then you're going to choose. I'm going to choose this to be u and this to be dv dx. This to be u, so u is x, and dv dx is cosine x. So you can think of it just, if you don't like dv dx, because this just has dv, you just think about
integral cos x minus sin x. No.
All right, and then you got to do one differentiation and one integration. One differentiation, one integration before you integrate in parts. So the derivative of x is 1, and the integral of cosine x is, isn't it just positive sign? Yeah, positive sign. Okay. And then we fill in this. So, so if you're wondering where the dx went here, they end up cancelling out. Dx and dv dx cancel out. Anyway, so u times v, u is x. V is sine x minus the integral of v, which is also sine x again, du dx, which is 1. Yeah. Okay, so I can leave out the 1 here. Okay, and the dx is cancel, if you will. Okay, so I got to integrate sine x. X, sine x, and then the integral of sine x is minus cosine x, and plus a c. Then we'll always have a c here. Okay, that's minus minus, that's plus. So we end up with x sine x plus cosine x plus c. All right.
Would it not technically be minus c, or is the plus c on the outside of it entirely? Or does it not matter?
Good question. It doesn't really matter, because it's going to be a constant anyway. If the constant turns out to be negative when we work it out, then we know, okay, well, it doesn't. So if it's like multiplied by 2 or something, you can also just leave it. If it's if you get a natural log or something, then include it with the c. Maybe a test to make sure this works. So how do I test to make sure that worked correctly? I would then derive it and hopefully find back at x cos x. If I derive it and I don't get that, then I've made a mistake somewhere. And also we look at, if we pick the other way around, would we recognize in the exam if it is wrong? Okay, so let's derive just as a test. So I'm just going to test here. You won't have to do this, but maybe if you had time in an exam, you could test. So if I derive this, what do I get? So this would be a product rule, wouldn't it? X sine x. So the first by the derivative of the second. So x times, what's the derivative of sine x? I think it's just positive cosine x for derivative. Yeah. First by the derivative of second plus the second sine x by the derivative of the first. It's just going to be plus sine x, isn't it? And then yes, okay. And then what's the derivative of cosine x? Negative sine x. And what's the derivative of any constant? 0. So bang bang, that disappears. Fantastic. We're left with x cos x. Very good. Okay, but the alternative could have been a solution. So we've done the question already once, we've tested it once, we know we have the right answer. But what happens if we chose poorly? If anyone's Indiana Jones fan. So we start our question, we write u is equal, v is equal, du is equal, and dv is equal. You don't have to write the dx if you don't. Let's say let's say we picked cosine x here and we picked x here. Picked it the other way around, the wrong way around. So there's only 2 functions, so we only got 2 real choices here. So I derive, and integrate. So derive the cosine x, I get minus sine x. And now integrate x, we get x squared over 2. Okay. My first red flag here is that this is looking more complicated than that. The derivative of the x towards the 1 is very nice, but all right, let's write this out. Okay, so we need to fill in our formula. U first, so that's cosine x. V next, that's times x squared over 2, minus the integral of v, which is x squared over 2, times the du one, which is minus sine x. So I got a minus sine x here. And what you will notice is that this is actually more complicated than our original. And you would have to go, it is possible, and you may have done examples like this in the past, of doing integration by parts twice. So having to actually integrate this by parts as well. But then you would end up, let's say you picked it the same way around, you'd end up with an x cubed the next time around. So the x is actually getting greater in value because you keep integrating the x. Or, what's wrong with this?
What does that say? I can't read it.
Oh, minus sine x. X over 2. Yeah, so I integrated that. So it's just getting worse than before. The actual bit we have integrated is worse than our original. So that's what can happen. So I would just stop here and go, okay, that looks worse. So this integral should look better. Not always, but and if you could go on integration by parts again here, and there's a few tough exam questions. We have to do that again. So pick your u, pick your v. So normally the one with the x, if it's just an x, pick that for our u, because we know it integrates down to something easier, or differentiates down to something easier. All right, let's do a second example. And then we move back to our, whatever you call it.
Wait, so how are you meant to choose which one to?
Yeah, so there's no set, like I can't say you definitely pick this. Well, let's look at more examples. If there's an x on its own, ever, pick the x as u. Like if there's an x or like 2x or something like that, pick that as u, because that derives to a constant, which makes it much easier, okay? So in